Just imagine anytime I start the class, I should record because I might just keep my mind. So I'm just recording now. So the next one is exact equation, right? No, I don't think it's exact. She is exact. I think that's 5.3. It's not really exact like that. Is it exact? This part, this 5.3. So what is it called? I've forgotten. I know it's the equation of one particular form. Like capital BX. You said? I didn't get what you said. Can you? Your network is bad. I can't hear you, but let me just do the question. Let me just. I think I remember. The equations lead is like equation leading to like homogeneous equation. That kind of equation they lead to homogeneous equations. I know it's something like that, but equation of this form dy dx, this is equals to ax plus by plus c all over ax plus by plus small letter c. Is that it?
Yes, yes. Equation is equal to homogeneous form.
Okay, equations reducible to homogeneous form. Yes, I agree. Okay, so equations reducible to homogeneous form. Reducible to homogeneous form. Okay, so there are some criteria we look at here. I think I still remember this thing. So there's some criteria we look at in here. Can I still remember, Sha? I think okay, okay. Let's just continue first. So let me look at one question, for example. Let me take a question, for example. I think this is one. So let me take, which one should I take first? Should I take, let me take question, let me take question two. Everything is just somehow, Sha. Everything is just somehow. So let me take question, what should I take? You just choose that, you choose, I think I don't want to choose. You said?
Okay.
Which question should you choose like this now? Question what?
Number one.
Let's do number one. Let's start with number one. So dy dx is equals to x plus 2y plus 3. Dy dx is equals to x plus 2y plus 3 all over, what is this now? 3x plus 6y plus 7. 3x plus 6y plus 7 apparently we are going to look at something. So if you look at this guy, I can write this one to be x plus two y plus 3 all over 3 into bracket x plus 2y plus 7. Now, before you can do something like this, there's a way they used to check it. They will do something like when you do what do they used to do again, sir? What's that condition? That condition, me, I don't need to check it. I know what I want to do, but I'm just trying to remember that condition. They'll say if I remember now. So if AB is equals to AB, then you should be able to substitute something. So if AB is equals to AB, like if capital letter A times small letter B is equals to small letter A times big letter B, then you should be able to substitute, make a substitution whereby make a solution that if you want to make a solution that simplifies the problem. But if not, then you are going to be solving this numerator and denominator simultaneously to deal with this guy. So in this case, if you check, my A is 1, so my capital letter A is 1, my capital letter B is 2, my small letter A is 3, my small letter B is 6. So if you check it, AB is 6, while AB is also what? 6. So they are the same thing. So if this is the case, then you should be able to substitute something that will simplify this problem. So since it is the case, I was able to see something that is common to top and down. So what I'll just say from here is that, so from here, so what is common to both sides? I will now say let say V to be 2x plus, sorry, x plus 2y. Do you understand what I'm saying? So if this is the case, if V is equals to x plus 2y, it means dv dx. So let me just say I'm continuing from here. It means dv dx will now be equals to 1 plus 2 dy dx. All right. Now I'm going to come from here. So let me just try to simplify this answer. So here I have 2 dy dx is now equals to dv dx minus 1, right? Right? Hello, are you there?
Yes, sir.
Then I'll come here. So from this place now, if I multiply both sides by 2, because I have 2 dy dx, I have 2 dy dx is now equals to 2 times x plus 2y plus 3 all over 3 into x plus 2y plus 7. So from here, can I make my substitution? What's 2 dy dx? dv dx minus 1. So I'll say, and now dv dx minus 1 is now equals to 2 into bracket v plus 3, because x plus 2y is v already, all over 3v plus 7. Am I making sense at all? Hello? Are you there?
Yes, yes,
Okay. So I will now have, so dv dx, I'll send -1 to the other side. So dv dx is equals to 2v plus 6 all over 3v plus 7 plus 1, so that I can erase this part now, so that I'm going to have dv dx to be equals to 2v plus 6 plus 3v plus 7 all over 3v plus 7, and this is equals to 5v plus 13 all over 3v plus 7. So I'll send the v part to the other side and dx to the other side, so that I can have 3v plus 7 all over 5v plus 13 dv is now equals to dx. Then I can integrate both sides. Are you clear to this side, to this point? Are you clear to this point? Can we continue? Okay, now to integrate this part, you cannot integrate this one and this guy directly like this. So what are we going to do? Since they have the same power, the numerator and the denominator has an algebraic form of the same power. We can first of all reduce it by doing long division, like simplify it. It's just like if you have improper fraction, you can write it in form of mixed fraction. So we're going to do a long division. So we're going to have 3v plus 7 divided by 5v plus 13. So we're going to do 3v divided by 3v. Sorry, 3v divided by 5v. That's going to give us 3 over 5. 3 over 5. So this 3 over 5, we use it to multiply everything here. So 3 over 5 times 5v, that's 3v. 3 over 5 times 13, that will give us 39 over 5. Then we subtract. 3b minus 3b, 0. 7 minus 39 over 5, that's minus 4 over 5. So since this is a constant, there's no way I can divide this by 5b. I'm going to stop my division here. So my p over d, that is my polynomial over the divisor, will now be my quotient plus remainder over divisor. This is just polynomial division. It means 3v plus 7 over 5 plus 13 will now be equals to my quotient, which is 3 over 5, plus my remainder divided by this divisor. So instead of having to integrate this is what I'll be integrating entirely. So I'm going to be integrating quotient, which is 3 over 5, plus That is because I have minus 4 over 5. 4 over 5. That's the remainder. I do it like this. 4 over 5 all over the divisor. That's 5b plus 13. So this is what I will be integrating. By the time I simplify this one, I will still have this guy back. So is that clear to this point?
Yeah.
So this is equal to x plus c. So if I integrate 3 over 5, I will have 3 over 5b. If I should integrate, let me just bring 4 over 5 outside. So if I integrate 5b, 1 over 5b plus 13, I will have times, I will have 1 over 5 ln 5b plus 13. Do you agree? Alright. So which is equal to x plus c. So finally, our final answer is 3 over 5b minus 4 over 25 ln 5b plus 13. Which is equal to x plus c. But don't forget that what we are integrating is in the form of y, x comma y. It's a function of x comma y. So you have to substitute what b is, which is what x plus 2y. After you make that substitution, that is just all. That will be all. So it's not something that is difficult at all. So what is the next question I want to solve with this now? You said?
Question number two of exercise 4.2.
Number 2.
Yes, of exercise 5.2.
Of exercise 5.3.
Yes.
Are you sure we should do number 2? This one, right? They are like the same pattern, so I don't want us to do number 2. Number 3 too is okay. Number 3, let's do number 3. Number 3 too is of the same pattern because I can factorize. Look at number 2. If I factorize 2 from 2x plus 4y, I will have x plus 2y. That's going to be a substitution. Number 3, if I substitute 2 from 6x minus 2y, I will have 3x minus y. That's going to be a substitution. My v is going to be 3x minus y. The same thing with number 4. The same thing with, okay, I think number 5 is different. Yeah, number 5 is a different kind of problem. So let's do number 5 instead. Do you understand? So 2x plus 3y plus 1 dx. So I will use this. Can you dictate that number 5 for me again, please? 2x plus 3y plus 1 dx. Okay. Plus what? Okay.
Y
3x.
x plus y plus 2 bracket close
Plus 2.
y equals 0, giving that y bracket open 2 equals to
Is equals to what?
minus
Minus what?
2.
Okay. So apparently we can just so before I even go further, I can just say okay, say take this one as the any way you write it doesn't matter. So I will say I'll conclude this first. I'll take this and this. So I can say take 8 with 2, take capital letter B with 3, take small letter A. So how do you identify these people? How do you identify this kind of equation? So first of all, they are not going to be, as you can see how they are. First of all, they are in linear form, and they are going to be having constant. Look at, you have 2x plus 3y then plus 1. You have x plus y plus 2. So they'll be having constant. Two of them might not have constant, but one of them will have constant value. So they will have constant, so they cannot be homogeneous in the first place. So they are always in this kind of format. So that's how you identify equation reducible to homogeneous. So now I'll do A, B, that is capital A and small b, and that is what? 2. But A, B is what? Small a and capital B is what? Is 3. So they are not the same. In this case, that they are not the same, we are going to solve this equation simultaneously. So since they are not the same, we are going to solve this simultaneously. So what are we going to do? So we are going to say, okay, no wala now. We are not going to say, okay, 2x plus 3y plus 1 is equal to 0. We equate this one to 0. We equate this one to 0. The second one, x plus y plus 2 is equal to 0. So we are going to solve these two simultaneously and find our x and y respectively. So I can just say, okay, so let me call this one equation 1. Let me call this one equation 2. To eliminate x, I can just multiply equation 2 by 2. So I have 2x plus 2y plus 4 is equal to 0. So now call this one equation 3. To eliminate y, I can multiply equation 2 by 3. So I can have, so I can have 3x plus 3y plus 6 is equal to 0. Let me call this equation 4. So now what I'm going to do is that to get my y, I can do equation 1 minus equation 3 so that I can delete x. So 2x minus 2x, 0 gone. 3y minus 2y, that's y. 1 minus 4, that's minus 3. 0 minus 0 is 0. So that implies that what? Y, let me just call this one y naught. Y naught is equal to 3. I will now say, okay, to eliminate y, I will now do equation, let me just do equation 4 minus 1. You can do 1 minus 4, any which way you want to do it. Equation 4 minus 1. So by doing equation 4 minus 1, I will have 3x minus 2x, which is x. 3y minus 3y gone, 0. 6 minus 1, that's 5. 0 minus 0 is 0. So that implies that what? I will say x naught is equals to minus 5. So after you have gotten this thing now, the substitution you are going to make is this. You are not going to say, okay, I've gotten my x naught and my y naught. I'll now say, let my original x and y in the equation, original equation now be, so let x That's my small x. So now it's going to be capital X plus x naught. So I'm going to say, okay, my y, my small y also to be capital Y plus y naught. So substituting above in the above differential equation, I will have 2 into bracket capital X plus, I don't want to waste time. So if I substitute those things above, everything is going to remain the same. It's just that the constant value, is not going to remain. So, but all your capital X and all your small x and your small y become capital Y. So I'm going to have 2 capital X plus 3 capital Y dx, that's capital dx, plus x plus y. By the time you substitute, that's what you are going to have eventually. So I don't want to go through the stress of having to write it again. So x plus y dy is not equal to 0. So in this format, I already have an homogeneous equation like this. So just to separate it. So how do you write in the homogeneous equation form? Divide all through by the highest power of x, which is x is by 1. So I'm going to 2 plus 3 into, then need to put brackets in, y over x dx plus 1 plus y over x dy is equal to 0. So now in this format, let me just write everything as dy dx, so I can have dy dx is now equals to I'm going to have minus 2 plus 3y over x all over 1 plus y over x. I hope you understand what I'm doing here. So, our substitution for homogeneous equation is y is equal to what? Vx. And if y is Vx, since dy dx is v plus x dx. So moving on, so I will erase this part like this. So the next thing I'm going to do is, so my dy dx becomes v plus x dv dx, which is now equals to minus into 2 plus 3v all over 1 plus v. So I will now have x dv dx now be equals to minus into bracket 2 plus 3v all over 1 plus v minus v. So I can now have x dv dx now be equals to minus 2 minus 3v minus v minus v squared all over 1 plus v. Simplify this. Let me just do a minus so that let me just factorize that minus. So our v squared minus 4v minus 2. Sorry, v squared plus 4v. These are factorized plus 2. These are factorized out minus all over 1 plus v or v plus 1. Any which way you want to write it. So the next thing is to separate the v and the x. So I can now have 1 plus v all over. So let me just put the minus here. All over v squared plus 4v plus 2 dv is equals to dx over x. Now, they now integrate both sides. Now, to integrate the right hand side is easy. But how do you integrate the left hand side? Now, to integrate the left hand side, if you see it's some kind of not really complicated. So you are going to do what we call completing the square method. Before you do completing the square method, since that if I differentiate what is on the at the denominator, you are going to get an algebraic expression of power 1, and that is exactly what we have at the numerator. So you are going to write the numerator to look like the derivative of the denominator. So what do I mean? If I differentiate the denominator here, I have 2b plus 4. So let me circle this guy. So I want to write 1 plus b to look like this guy. So it's means I want to do some manipulations there. So I don't want to do some kind of long method of doing that. So I'm going to explain the long method. Maybe I don't know, maybe not today. So if I should multiply this by 2, if I should multiply the numerator by 2, what do I have? I have 2b plus 2, right? But I have to divide by 2 so that it will look like I didn't do anything, right? So that I won't tamper with what I have. So I have to divide by 2. So I'll have this 4b plus 2 dv. This is ln x plus c. Or let me say ln kx or probably there or ln k. Let's ln x plus c for now. But what I actually need at this numerator is 2x plus 4. Okay, you can still get there. So here now I'm going to do 1 minus 1 over 2 integral of 2v. Next 2v plus 2. So how can I write plus 2 again? I can write plus 2 as well, plus 4 minus 2, right? So I can have 2v plus 4 up there. So v squared plus 4v plus 2 dv is equals to ln x plus c. So here I can now separate it. Minus 1 over 2 integral of, I will now have 2v plus 4 all over v squared plus 4v plus 2 minus 2 all over v squared plus 4v plus 2 dv is equals to ln x plus c. I hope you understand to this stage. Hello, are you there?
Yes, I will understand.
Okay, now, so the integral of this one is now ln of the bottom. So I will now have minus 1 over 2 ln v square plus 4v plus 2. And I have to deal with this one plus. So what I have to deal with is this second integral, which is 1 over v squared plus 4v plus 2. Because minus half, so I said I want to get plus 3, I'm adding plus 3. So basically, minus half times minus 2, that's plus 1. So that's why I have positive here and I have 1 here. So what I need to do to this denominator now is to do completing the square method. So basically I've done, we've integrated this one, we've integrated this part. It's just to integrate this one. So I will not have to be writing all of this again. So I'll just be writing this. So continuing with this one, I want to integrate. I will have integral of 1. So how do I complete the square? I will deal with the coefficient of v square is 1. So since coefficient of v square is 1, I will, if it's not 1, I have to factorize out the coefficient of v square. Let's say coefficient of v square is 2 now. I have to factorize 2 so that I can make coefficient of v square 2. So since I've checked that coefficient of v square is 1, I check what's coefficient of v? 4. Divide coefficient of v by 2, which is 4 divided by 2. I have 2. Square 2. 2 square is equals to 4. So what do I do with this information? These are the two information I need. This get divided by 2 and the result square. So I'm going to have v squared plus 4v. Then I'm going to add the result I squared. I'll add plus 4 to it. Then I'll subtract out 4 again. Then I'll put this plus 2 that is here. So apparently, what does it do? By the time I remove plus 4 minus 4 is 0. So I have v squared plus 4v plus 2, which is my original question. So I've not done anything more. So from this place to this place, I have a complete square. So I'm going to have integral of 1 all over. So that's apparently v plus 2 all squared. Do you agree? Minus 4 plus 2, that is minus 2. So that is minus 2 dv. Yeah. So apparently I'm just going to write it in form of v squared. So I'll say 1 all over v plus 2 squared minus, I'll say minus root 2 all squared, because 2 is still same as root 2 squared. And don't forget that we did something like this, that any integral of this format, so 1 over x squared minus a squared dx is going to be 1 over 2 ln x minus a over x plus a. We did this one in the last question, that was the last question I think we checked. So this is going to be, this is going to give us 1 over 2 ln v plus 2 minus root 2 all over v plus 2 plus root 2. And that's that. Do you understand?
Yeah.
So we just need to bring this that we got from here and just throw it inside this place. Then after we have done that, you just need to substitute. So let me just put a direction to that side so that you know that I'm picking this square to this place. So after you've done that, you have to substitute what your v is, which is what let me erase this part. Then you substitute v to be y over x as capital Y over x. Substitute v to be y over x. Recall that v is equal to y over x. That's capital Y over capital X. So after I've substituted that, you are not done. So after I substitute v to be y over x, what is it? We are not dealing with capital Y and capital X, we are dealing with small x and small y. So we call that what? Small x is what? Big X plus what? Your x naught, that's the value of x naught that you got, and small y is big Y plus y naught. So after I substitute as big Y over big X, you now substitute big X to now be x minus x naught, and big Y to be what? Small y minus y naught. Do you understand? So, and that will end the question. That will end the solution of the question. Yeah. So I didn't know I was on mute. I didn't know I was on mute. Is this how it was in? Is it how it is inside your book? This equation. What did you say?
Yeah.
So one is said to be exact if my is equals to nx. So what do I mean by this? It means if I should differentiate m partially with respect to y, and I differentiate n partially with respect to x. If they are the same, then you say that equation is exact. Else, it is not exact. So given this condition, how do you now find, if this condition holds, how do you find the solution to the question? There's a way you do it sometimes. You use grouping method, you use some kind of method. You use they call it grouping method, and they call one grouping method, they call one what method again? I can't remember. I know the method, but I can't remember what they call it. I can't just remember. So you say there exists. So there exists. So I can say if my is equals to nx, then there exists a function f of x comma y as which is the solution to this problem, such that the partial derivative of f with respect to x is equals to n, and partial derivative of f with respect to y is equals to n. Is that how it is written in your booklet? Did you see this inside? Then if I have this scenario, and I can say, okay, I can say if this holds, then that implies that our f is going to be the integral of, don't forget m is a function of x and y, integral of m of x comma y dx plus the function of y, say phi y, because if I'm integrating with respect to x, since m is a function of x and y, there's going to be a constant function which is going to be a function of y. So if I have this, then having it at the back of my mind that if I differentiate partially f with respect to y, I have n. So then I will say df dy is going to be equal to, so going from this place, that is going to be n. That's going to be n of n of x comma y. We are going to write that. Okay. And that is going to be d dy of the integral of m x comma y dx. If I differentiate phi of y with respect to y, I will have phi prime of y. So if I have this case scenario, so if I have this is to be equal to this, so if I have this to be equal to this, I can now say my phi prime of y is equal to n of x comma y, like making phi prime of y solid of the formula minus partial derivative of d dy of integral. This thing will come out in your theory question for integral of m of x comma y dx, like this. So if I have phi prime of y is equals to y, it's equals to this. How do I find phi of y? So to find phi of y, I have to just integrate both sides by y. That phi of y will now be equals to integral of the whole of this, say n of x comma y minus the partial derivative of this equation gets to y of integral m of x comma y dx with respect to what? With respect to y. So apparently this is my f. Let me call this equation 2. So for my f, I've gotten my f here, but what do I need to get for my f? I need phi of y, and I've gotten phi of y here. So my f will now be having me to substitute this one here. So my f is now equals to f is now equals to integral of m of x comma y dx plus my phi of y, which is the of this, plus integral of this inside bracket n of x comma y minus d dy. So it's just a step-by-step process. There's nothing difficult in it. Of integral of m of x comma y dx, then dx, and close the bracket, close the y, and that's just it. It's quite easily done. So that's just the concept. There's this method they call this. I can't remember. So your f, which is the solution, is now this expression. So on Wednesday we are going to meet again. So on Wednesday, do you understand the whole concept, the whole breakdown before? You said? I didn't hear that. What did you say?
No.
You didn't understand?
Exactly.
Okay. So from where didn't you understand? From where? From where? From equation 2. So from equation 2, this is what happened. From here, if f is the solution, then so if this is exact, if this equation holds, then there exists a solution f of x comma y such that if I differentiate that solution with partially related to x, I'll get m, and if I differentiate partially related to y, I get n. Now, if this holds, if I want to get f, I have to integrate with respect to x, right? So if I integrate f with respect to x, I have f. If I integrate this part with respect to x, I have f. Now, if I integrate m is a function of x and y. If I integrate it with respect to x, I will have a constant called a function of y, because if I integrate it to x, y is like a constant, right?
Yeah.
So I'm going to get a constant called y. It's just like, okay, if I want to integrate, let's say I have a function of xy called call 2x plus 3. Let me say 2x plus 3y. So if I integrate this guy with x to y, I'm going to have, is x to x, I'm going to have x squared plus 3xy. Then I'm going to have a function of y, say let me say for example, exponential x. You know, if I differentiate this guy with its respect to y, I'm supposed to get this back. So if I'm differentiating x to x rather, what I'm saying, I'm going to have a function of y. Am I writing exponential x, exponential y? I'm going to have a constant called a function of y. So I don't know what that function is. That's why I'm using phi of y. So let's say that function is exponential y. If I differentiate this guy with x to x, it means that this exponential y is going to be what? 0. So it's like a constant. So we are integrating a function of two variables. So the other variable is going to be a constant. It's going to be used as a constant in that case. So that's why if I integrate n with respect to x, then I'm going to have a constant value called y, the function of y. So that's why I have this guy. Do you understand this one?
Yeah.
So now if I differentiate this, the reason I'm differentiating this is because I want to use this condition here. So if I differentiate this f with respect to y partially, I will have this. And I've already said that it's going to, if there is a solution like that, this is going to give me n. So that's why I say it's equal to n of x comma y. Now, differentiating, you know, if I'm doing partial derivative, I have to do it for both sides. So differentiate this place partially with respect to y. It means d dy of this integral, which is what I wrote here, plus if I differentiate this one with respect to y, I'm going to have phi prime of y. Do you understand? So now, making this one instead of the formula, I have this, then I'll send this one to the other side. I have minus d dy of this dx. Do you understand now? Now, if I should need phi of y, you know this is phi prime of y. If I need phi of y, I have to integrate with respect to y, right? So integrating the whole of this with respect to y, that's how I have this integral. Then encompassing all of this inside bracket, then put the y outside. Do you get the logic? So this phi of y is what we are looking for in this place, this stage here, because that's our f. So I just chew all of this into this place, and that's what gave us this part. So it's very simple. Do you understand now? So you just have to go through it. There's nothing difficult in this. It's very simple. All right. So that will be it for today. We are going to see you on Wednesday, right? All right, just try and look at it, and I think you should be able to work fine with it. So that question is going to come out. It's going to come out. If you look at maybe, what year did I take this thing? So let me check. I think let me check for 2016. If you look at the first question, 2016, you're going to see. We check first question 2016. Let me just check. 2016 first question. You're going to see that you see, yes, question 3A. Question 3A, exactly. Did you see that? Did you notice? So question 3A is the one that will give you that problem. So that's exactly so.